Okay. Ready? So, in this second half, panel 4, we are going to shift the focus to emerging challenges and solutions from legacy systems and AI, threats to FRMCS, and secure patch deployment. These topics are critical as we move toward a more connected and resilient ecosystem. And let's welcome So, next speaker, Omar.
Okay, so I'm gonna talk about a more modern thing that the analog valises. The purpose of the talk is to have a high-level view on the usage of artificial intelligence from the both sides, for the good and for the bad. So from the attacker's perspective, and then also how the defenders could be using it specifically on the rail industry. Also, most of the things I'm going to explain can be applicable also to other sectors. You can find me very easily on LinkedIn, so I will just jump this. So I have cybersecurity background, and for 7 years working specifically on rail cybersecurity. We all know about artificial intelligence. Most of us, we are already using it on our daily life, and we are going to use it more and more in the future. So I want to focus this presentation on what's possible today. I'm not going to speak in the future because for sure it will be a lot of evolutions in very short time, but I'm really focusing on what's the reality as of today. And it's already in use by attackers, and we will see some concrete examples of it. But before, I want just to give a quick overview, not about the artificial intelligence only, but about the rail cybersecurity, where we are now, because it's important then to link it to the artificial intelligence topic. So we all know that digitalization, it's here in rail now to stay, and it will be the trend to keep increasing the usage of digitalization and connectivity. So in the past, we had a lot of isolated networks. The trains, the rolling stock were not really much interconnected, and today this is not the case anymore. Any new fleet is having a lot of connectivity with the infrastructure, in some cases with cloud services even. So we really had a change of paradigm in the last 10 years. And also we have more and more automation in terms of automatic train operation, going even to driverless trains where we don't have a driver anymore. So we came from the situation where we always have a driver on the train with emergency stop, that is electromechanical device to stop the train if something goes wrong, to the current situation where we can have fleets that there is no driver, and that if there is a cyber attack, the impact might be much higher. So we have an increase of the attack surface on one hand due to the increase of connectivity, and we have an increase of the potential impact in case of a cyber incident. So in the end, what we have is a huge increase of the risk if we compare the situation 10, 15 years ago. And this is the reason that now there is a topic that is rail cybersecurity, and in the past it was not existing at all. At the same time, business continuity and availability, reliability of the rail systems keeps to be a very important thing, and this brings constraints on how you can implement cybersecurity, because you need to ensure that any cybersecurity control you bring into the rail industry is not a threat itself to the availability of the system. We have safety critical systems and regulations. You all know we are at the CENELEC event, and so you know it's a highly regulated sector, and this is also bringing some constraints on how to implement cybersecurity sometimes. And artificial intelligence, it's already been used. When I was preparing the slides a few weeks ago, I found this new, in fact, that it's very small maybe, but there is this research firm, ESET, who published that they find the first sample of a malware that it's using local artificial intelligence to develop on the fly the scripts to attack the system. So it's a ransomware, but instead of having the scripts already developed, what it does is based on the files that it's seeing on the system, it develops automatically the scripts to it decides if it will be better to encrypt the data or delete the data or exfiltrate the data, depending on which are those files that are being seen on the system. So this is the reality. It's not working very well, this first malware, but for sure it will improve quickly, and we will find more and more this kind of malware on the fly. What else can the attackers do using artificial intelligence? They can use it to do reconnaissance. We saw this example of crafting malware for making much better phishing and ransomware. If you go to spam, and you check some of the mails you are receiving now are not anymore so obvious that those are phishing. They are really improving, especially on the multi-language field. That in the past you read something in Spanish and it was clear that this was not an Spanish mail. Now it's not possible anymore. We have the deep fake attacks. And something that I found a lot of times, especially when I joined the rail industry, was the argument that was saying that, okay, but nobody knows rail out of the rail experts. It's very difficult to attack or to understand how rail system works. So this kind of security by obscurity that never work, in fact, because any actor that is having the motivation, the time and the resources will bypass that for sure. But what happens with artificial intelligence is that the bar for bypassing this security by obscurity is really low now. And this is what I want to show you here. I did a very silly exercise just to play around with ChatGPT. I told her that I'm a cybersecurity consultant and I want to do a pen test on a rail system, so I asked for some advice. Let's imagine I have zero knowledge about the rail and I want to learn a bit about it. And it turns out that it's very useful. It gives quite nice advice on how to do the initial reconnaissance, how to do network mapping with concrete strategies for doing that. Also some nice ideas on how to do wireless attacks, how to do man in the middle, try to do jamming, try to do denial of service, and so on and so forth. So how it also suggests to do fuzzing, to try to inject some messages on the proprietary protocols specifically from CBTC signaling. It also suggested to have a look on maintenance ports and interfaces and debug ports like the GTAG that we know are very often inside of the devices and can be a good source for attackers, to try default credentials. Then I ask why are you suggesting the CBTC and specifically the APT and the ATO, and give me some context that those are important systems, right, that can have a big impact because are the most safety or one of the most safety related systems within the rail ecosystem, and that it could be a good focus for the investigation because they are safety critical, because usually cryptographic protocols used on them are not the most secure ones or the standards, and the potential impact is very high, right? If you can stop a train or make a train go faster than it should in a given section, so that will have a lot of visibility. So as you see, it's really making sense, all the advice that you can receive. Then it can also propose some position for doing the sniffing of the CBTC traffic, okay, try to avoid the areas that are very crowded, but you can go to the platforms or void areas. You should be at 3 meters high to increase the visibility. stand 20-30 meters from the uplink antenna to maximize the effect. But let's imagine I never saw a CBTC system. I have no clue of what are those antennas. Okay, you can ask for some pictures, and it will provide you with concrete examples, and now you can have a better idea of what you are looking for exactly, and then you can look for the best spot at 20-30 meters for doing the sniffing of the traffic. You can also ask about let's generate some traffic, let's generate some CBTC kind of traffic. So it is very kind. It can provide you one script to generate pickups that will simulate. It's not exactly CBTC traffic, but the schema that it creates, it's quite similar to what you can see on most of the vendors. So you can start having some concrete examples to play around. But you can go deeper. In this case, I just hide it to avoid mentioning any concrete manufacturer, but I ask for information about one specific system from one specific vendor. Okay, this model of the CBTC system of this vendor. And he told me, okay, I cannot give you traffic, but it gives you some ideas on how you can get the specific traffic for this system, like which standards the system is based, and where to look for some white papers and public available documentation to learn more about this specific system. And of course, it says, and you can ask the vendor under NDA. Okay, thank you. That's for sure. But something you can do also is to ask in which specific operators this specific system is used. So imagine you did the investigation and you know you have now a vulnerability identified for this vendor. It can be very useful also to figure out in which specific cities and operators this specific version of this specific system it's being used. So it can give you some ideas around it. So again, it's a silly example, but just to make my point that security by obscurity, so saying that, okay, nobody knows rail protocol, rail system, that's not anymore an argument, a secure argument, and we should think that now it's very easy for any potential attacker to figure out all this information. Now, moving to the defender side, there is also a lot of advantages that we can already take from using artificial intelligence. I'm having here just few examples. One is using it to find anomalies on the traffic and in the system, and I'm doing another presentation after lunch, and I will put more of the focus here with concrete examples. It can be used also to get this expertise as the attackers does, but for the defenders in the two ways. For the rail operators to better understand cybersecurity and how to bring cybersecurity on rail, and for the cybersecurity people, cybersecurity analysts, also to better understand the rail. It can be used also to speed up and to have a easier view on what is the security posture of the systems to be defended. And we'll see also some examples later. And also one of the big difficulties or the big headaches on rail, it's how to deal with the cybersecurity of all the supply chain, because usually it's a huge supply chain, and also there are a lot of new tools, commercial tools, and that can be relied to make it a bit easier and lighter. So to finalize, artificial intelligence is reshaping the way we work, the way we interact with technology, and it will have more and more impact in the incoming years. So we should, and the attackers are already taking advantage of it. So we, as defenders, we should also be already using it and not waiting any longer for doing it. So thank you very much.
Our next speaker is Martin.
The end. Thank you, I've got it. Hello everyone, well thank you very much for allowing me to speak here. I'm Martin Reed from the University of Essex in the United Kingdom, and I'm here as part of some work we're doing with the Datacom Industry Alliance, which is a new industry forum to look at Datacom generally, and in particular we're looking at part of work which is looking at cybersecurity in FRMCS, which is why I'm here today. Now, I'm an expert in cybersecurity and networks. I've been doing that for a very long time, but I'm very new to rail, so please bear with me. Literally this year, I think, is when I'm starting to learn about all of the things in railways, learning a lot in this meeting about all the standards. So briefly, I'm going to introduce FRMCS in case you're not familiar. I think most people are familiar with a lot of it. We'll look at how it works in rail, how the mission-critical services are a handover between those, and then some implications for the wider deployment of this technology, and a little bit about some of the research that we're interested in looking at this area. So the FRMCS really is a 5G system, the same as we're using on our phones now in many ways, implemented though in a specific way for railways. And it's tracking so FRMCS is tracking the 3GPP releases. It's interesting to look at the history. Some very canny people in railways way back in, well, it must have been 2013, 14, got the mission critical services put inside the 3G standards ready for when you need this technology to replace GSMR. So people obviously have been thinking about this for a long time. The mission critical things are mainly for systems like railways. I'm not aware of other places that use them. So while I'm very aware of 5G systems, I hadn't heard of mission critical services until I started looking at this railway part. It's not something you generally hear in other public 5G systems. And we're looking, to the future, that the first release of FRMCS likely to track either release 18 or 19 of the 5G standards. What is FRMCS to look at? I've got a diagram here. What we can see is that we've got the onboard side on the bottom left. That doesn't work on there, don't worry. On the bottom left, the track side, which is, of course, what we mean by track side, well, it's anything from the systems beside the railway, of course, also to the command, the control centres. And at the edges, there's an onboard or a trackside application interface that links to all the systems that we've been talking about. So automatic train protection, operations, voice systems, which allow us to communicate. And these are using these mission-critical services which have been embedded inside the 5G standard. There are some interesting things to see here from a cybersecurity point of view. It has to link with legacy systems or other systems, as they say in the standards. What does that mean? Well, it would depend upon the deployment scenario. So it could be linking with GSMR systems that you've got interworking between some parts which are using FRMCS and maybe other parts that are using legacy GSMR when you've got the interaction, or maybe older systems. It turns out that's the bit we need to really focus on. And I'll say a little bit more about that later, but there's, I think, a lot more work to be done there. How does the cybersecurity work inside FRMCS? Well, you have to sort of take apart the 5G part and have a look inside it. We can just have a little bit of an insight into how it works. So this is sort of a diagram of a 5G system. I used to tell everyone that nowhere uses as many 3-letter or 4-letter abbreviations as networking. And then I met some people, yesterday, no, rail uses a lot more, and I said, I'm not sure about that. But of course, as they pointed out yesterday to me, well, of course, railway uses 3GPP standards as well, so therefore, by definition, it uses all the ones inside there and all the ones in railways as well. So I'm learning about the railway ones. This is not a complete 5G system. This is just a few of the very small components which make up a 5G system. And let's see how they interact. We can imagine a train has come along, it's left its previous wireless base station, G-Node-B, which is a strange name in the 3GPP standards, but basically the wireless base station there at the bottom left. First thing it does is talk to that to build a wireless connection. At that point, there's no security as such. It's just I need to talk to you and start building a relationship. The next stage is that the train then has to identify itself, and there's a database, the Unified Data Management block at the top there, which communicates and contains all the information, got all of the IDs. So IDs have to be preloaded, all the certificates have to be preloaded, of course, onto the train. That is done in a way that maintains confidentiality. So even though there's no secure channel as such yet, the identity of the train is kept secure. So there's a very clever mechanism to do that. At this point, the train says, I want to talk to the FRMCS network, but it doesn't know for sure that the FRMCS network is who they say they are. So the next stage is the mutual authentication, using public-private key authentication systems, which require a lot of certificate management. Once that is done, then the train can know for sure that the FRMCS system it's talking to is the one that it says it's wanting to speak to. And only after that, of course, can you start sending data plane messages. And of course, what's different from existing older legacy systems is we're now, of course, using IP technology, Internet Protocol. Now, of course, that doesn't mean we're connected to the Internet. It just means we're using Internet Protocol messages. But, we showed on the previous slide, there's another other connection. Essentially, that connects to another network, that connects to another network. Potentially, somewhere along the line, there's an internet connection somewhere, even if it's just someone trackside bringing their laptop, plug it into a system to update the systems. And I know I've spoken to trackside engineers who will tell me that they are connected to the internet when they download that file from a vendor and update the system. So yes, there's no internet connection as such, but of course systems connected to the internet may interact here. So the other thing to note is that a 5G domain operating probably within a country or a single operator, of course, has to interact with other entities as well. So, for example, a train moving from France to Germany, it will need to speak between the FRMCS system in France to the FRMCS system in Germany. And for that, there's another block which provides a proxy for all the security between external networks. That's the Security Edge Protection Proxy. I'm not going to explain exactly what it does, but that is very much looking to make sure that security trust relationships are built properly within the FRMCS domain, or the 3GPP work. Once it's established that, only then can communication start going through. So it's a complex system. What can we say about this? Well, an interesting thing is to look at just one thing that can happen. So there's many operations within this, but let's look at what happens when, potentially trains move between France, a train going through France, it swaps in its domain, and let's pretend the ATP system is sending these mission critical messages to do that work. What happens when it goes to a new domain? So it moves from France to Germany. There is a number of different ways it could do this. The simplest way is to do the roaming just like many of us are doing right now. So you can roam, and I'm sure you're doing this. You've flown into Madrid airport, and all of a sudden your phone says you're roaming. Well, that's exactly what could happen inside this FRMCS domain as well. Now, if we do the roaming the same way we're doing it with our mobile phones, again, we have to talk to this Security Edge proxy, which is making sure things are done securely. But as you can see, the red line, for the automatic train protection or operation, there's quite a long path there going back to the home network. That's not something that you want to happen. So the roaming that we use on our mobile phones is not really appropriate for the train railway systems. So instead, a different system is in operation, likely to happen, and that's again the train. Let's look at the train moving. Now, what happens is that the train is talking directly to the German FRMCS domain, and at that point, it's now talking directly. There's no sort of dogleg communication link, as we say. So that's the way to do it. Now, one issue with that is that you need a lot of work to understand how all the certificates are managed. You still need it in the other one, but you need a lot more management here, I would argue, because now the train that was maybe in front, maybe it was a German train, in which case all fine, but maybe the French train moving into Germany now has to build trust relationships with the German infrastructure provider. And that requires, it's all doable, it's all possible, but it requires more management and more know-how, I would suggest. So, FRMCS. It's just one system amongst many other complex systems. I think that is the issue that needs to be thought about. Because FRMCS, if you look at it, looks very, very secure. Certainly no issues within that as far as I can see. And with thousands of people who looked at that. I think the real issue is how it's deployed. Let's just talk a little bit about that. I mean, how do you link with legacy systems? So FRMCS uses a zero trust architecture, and that's very new for many rail operators. I've said infrastructure providers, I mean the operators of the rail. That's a new architecture. And all of their existing systems, if they're going to bring them into the other link, which I showed on an area slide, they're going to have to somehow make sure they comply with that as well. And that requires an upgrade lift. So how can this zero trust work? Well, it requires microsegmentation. That's already built in inside the 3GPP standards, inside the ways that the 5G systems operate. But as I said, the infrastructure providers will need a lot of help from vendors and other organisations to bring themselves up to using these systems, in particular when they're linking with systems which are interacting from legacy systems. It's interesting that the standards themselves don't mention zero trust architectures, but how those are implemented is very much built within the standards. I'm very grateful for Marcus, who showed us the rail cybersecurity specification. I had a look at that this morning for the first time, and that showed me a lot of system. I think, yeah, that's exactly what I'd expect to see to support this. But rail operators are going to have to learn about implementing policy. The days of having, this is the username and the password for this particular bit of equipment, and I know that's a very outdated concept. If I speak to people who work trackside, they say they're still doing that sometimes. That is a completely out-of-date way of doing cybersecurity for these modern systems, potentially with connections to the internet eventually. So what does zero trust mean for FRMCS deployment? Well, it means solving things like understanding identity. It's not straightforward to deploy. It's not even obvious how you do deploy that inside a cybersecurity system. So the zero trust architectures come from the cloud environment. They don't directly translate to cyber physical systems like railways. The other thing is that if we look at the cryptographic standards, these need to work today, but they need to work maybe 2050, maybe 2060, beyond when I'll be alive. Now, we know that the algorithms will be broken by quantum computing. Not all of them, some of them. And so it's going to have to be mechanisms to make sure those update. And the 3GPP standards, they're going to be tracking that, but how do we make sure that's embedded in infrastructure which is being put in place, maybe today? So how can we, I'll go back one, how can we solve this? Well, using AI has been mentioned. That's something we work very actively in the University of Essex. So how can such things help with rail systems? Well, we need the data. So as researchers, we need access to the data. We can then train systems. produce machine learning models, and then help decide what is good and bad. But that's a big problem when we've got ultra-reliable systems. False positives in the web environment means someone can't access a website. A false positive inside a mission-critical system might mean a train stops because some cybersecurity integrity system has said, there's a potential fault there. So at the University of Essex, we're looking, using things like formal methods. Explainable AI. Explainable AI will allow us to see exactly what's happening. So in conclusion, FRMCS looks highly secure if you look at all of the standards, the way it's being implemented. And that's because, of course, there are thousands of people looking at the cybersecurity there. Later 3GPP releases will fix some of the problems such as quantum secure cryptographic algorithms. And in fact, that the highest risk is not within FRMCS itself, but how rail organisations are going to implement it, particularly linking with legacy systems. How they handle things like cross-domain handover between different organisations that may have different security policies. And finally, AI and machine learning, essential to tackle things like automated AI. Right now, today, automated AI systems are launching automated attacks. We want to find AI mechanisms to stop that. And that's very important in these safety critical systems. So thank you very much.
And our last couple of speakers, Julian and Julian.
So, hello everyone. We will present you today a Europe's Rail System Pillar topic from the PRAMS team. So basically it's the Performance and RAMS team of System Pillar. We'll present you how to deploy bug fixes and cybersecurity patches on a safe computing platform.
So everyone, my name is Julien Bois. I have an experience of 9 years in Alstom as a safety manager for CIL4 product, mainly EVC, ETCS on board, Eurobalises and land equipment units. Since 2019, I'm working for Eco Switzerland. Well, it's fine. Okay. No. Since 2019, working for Eco Switzerland, where I'm safety manager on different European initiatives. First on OCOA, so onboard CCS reference architecture. And since 2023, I'm the PRAMS co-leader, of the PRAMS team in System Pillar. And I'm also working in parallel as safety manager, as a project manager for Stadler on rolling stock project.
So Julien Spanot, I am head of rolling stock software for SNCF Voyageurs, so the French National Railways. I'm working there since 2008. Experience in software, TCMS systems, DORS systems, and I'm in part of several working groups of Senelec, IEC, and Europe's Rail.
So we decided to organize our presentation a bit in a practical way so that to get a real case example that could occur when we are deploying what we call safe computing platform. So let's imagine we have an onboard safe computing platform which is composed of a CIL4 operating system, a CIL4 hypervisor, and integrate two functional software. One is CIL2 and the other one is CIL4. And on this system, we choose two examples of issues that could occur when doing the lifetime of the system. So the first one is a safety issue. So in our case, we took a bug in the CIL2 software that prevents the train from braking efficiently in particular situations, so very specific to the project. But the fix is straightforward, so it's only one single line of code to change. And the other one is an availability cyber security issue. So it's a vulnerability in the SIL4 OS that could be exploited to prevent the entire chain fleet from starting up. And then for this, a patch must be implemented as soon as possible. So we say both are quite easily solvable. So then, as a project manager, I would turn to my safety colleague and say, oh, can we deploy them fast?
And as a safety engineer, I would simply hide. Why? Simply because for such, I would say, simple fixes, it can take up to a year, sometimes more, to fix the software, get it assessed, and put it on the fleet. And we did it in a few days, maybe a week. Why? Simply because we don't have common metrics for the common safety methods risk assessments. Every company has its own way of interpreting the criteria. We don't have in the legislation something called urgency, like a way to speed up the process if you want to have really fast, I would say, a fix on the trains. Also, we don't have clear rules for software development process, like the standard, the EN 5716, defines minor and major modifications, but don't give really ways to define what is a minor modification. And this is something that has to be fixed. Also, it's not really clear what kind of V-cycle we have to apply for the software development process. Also, for the I would say, the certification and assessment, our systems are currently monolithic, they are not modular, and we cannot make, I would say, a partial assessment of the system, so everything is complicated. We have to make the full assessment of the system.
So the big question is, can we change the situation to get bug fixes and cybersecurity patches deployed within days or weeks instead of months? And the answer is yes, we can. With what? So basically, we identified a list of elements that have to be considered. So first, we need a clear set of RAMs requirements, clearly defined and applied. A system pillar reference architecture, which is based on modular system, which defines harmonized interface, which are really supporting the freedom for interference as defined by standard EN 5716. We also need standardized metrics for consistency across suppliers and processors, so mean a common language on this quantification. We also need clear rules to complement 5716, not implement, to complement standard regarding software maintenance. And finally, we need also flexible assessment with different depths of analysis. So it will be defined a bit later. But basically, this will require additional effort for the initial assessment of the software. But for doing the whole lifetime of the system, the idea is that it will really help at decreasing the total cost of ownership of future CCS systems.
So we define within the Primes team, with the help of a colleague from the Cybersecurity team of System Pillar, a fast software development process to enable fast evolutions. Also, we wanted to define a new assessment process linked to urgency. We need to change the way to handle really, really urgent evolutions. Also, we want to give the most power as possible to the organizations so that they could, I would say, deploy their software faster without the need of a systematic assessment from an ISA, basically with making them auditable at any time, and I would say with checking every year if they are competent enough to handle such evolutions.
So basically, to reach the goal defined by Julien, we need this. We have defined a defined list of golden rules that have to be really achieved to have something efficient. So the first is that we really need to get, as much as possible, strict separation between cybersecurity and safety rules. Why? Because they have incompatible life cycles, I would say, and also to avoid also cascading effect, because basically a cybersecurity issue should not have an direct impact on the safety function. Should not compromise directly a safety function. That should not be possible. Then I talk about freedom from interference. So we need to make this element to be really effectively implemented. So with cybersecurity, I said before, but also between different functions, different software modules, different hardware channels, everywhere possible to really, again, avoid cascading, that you may modify one module and then the whole system may have impact because we have not properly bordered our system. Then we need this harmonized and seamless process to deal with evolution between all stakeholders, so suppliers, integrators, operators, assessors, authorities, so to have a common, let's say, set of rules for criteria or metrics, criteria, quantification, and also assessment shades. Then we talk about a capable and mature organization. That really means this process can only be applied by organizations that are really have a strong knowledge in the technical, from a technical point of view and from a process point of view. Technical, of course, because if we want to get faster evolution, we want to be sure that the people making the modification will not introduce again another issue while correcting the first one. So we need to have strong people from a technical point of view. And also from a process point of view, because they need to really be aware on how to use this future process, the CSM criteria, the 50716 for maintenance evolution. But also we need to have organizations that are really capable to communicate easily and clearly to all the different actors in the modular system, because this will be really a huge change in the modular system. There will be new actors, and this means more communication, and if it's not properly done, then it will collapse. So we synthesize every prerequisite that defined above, with more detail, of course, but inside a process for evolution management defined in system pillar.
Okay, thanks, Julien, for the theory. Now let's go back to our two examples. We will try to make it simple. So we go back to our examples. SIL4 OS, SIL4 hypervisor. We have a SIL4 software to fix and a SIL2 software to fix, each for their own reasons. We have to understand that I would say the situation is really complex, because we have in this situation 10 different actors. They all have different working methods, objectives. It's not easy for them to understand each other. We have 5 different building blocks that I listed on the top, and they all have different life cycles. That some will need to have some fast fixes. We will have for the platform to handle the obsolescence management. For the hypervisor or the operating system will have many different customers and not linked to our specific example. So really everything is complex.
And basically, so we are defining our evolution management process around 4 main steps. So the first one is the impact analysis. So it's basically based on the CSM criteria. So there are 6 criteria. Julien will detail them later. But we propose to create a new one, which is called urgency. So the urgency covers the necessity to deploy faster than normally an evolution on the field in case of RAM or safety issue, or in case of cybersecurity threats. But it's really important that urgency is not intended to reduce safety measures, but to consider the risk reduction when deploying a modification or a patch earlier, like during unmitigated risk exposure. And all these criteria are defined by 4 levels of granularity, from minimal to high. We took inspiration from a maintenance standard, SENEC maintenance standard, 17023. And all these criteria are combined together inside what we call significance matrix. And the score which is defined by this matrix will directly have an impact on hardware, software development processes. Also then testing strategy, which is not yet covered by our process, will be in the next phase. And then for the assessment strategy, which basically will lead at the end at 3 different types of assessment, depending on the criticality of the modification and complexity and other sectors. We call them a yearly letter of support, or a new certificate.
So if we go back to our example, the first one, we have a SIL2 bug in the SIL2 software. It prevents the train from braking efficiently, and the consequences are we have often some emergency brakes. So we will analyze every CSM criteria using a list of standardized metrics, and we will also add the urgency on top of that. For every criteria, we give a note. All the notes, we make a sum of all of them to get a score that we call a significant score. From that, we get some different level of significance that we use after in our process for software development, testing, assessment. So in our example, the first one is additionality. It's, I would say, the number of modifications we had since the last full assessment. Let's imagine that we had really a very small amount of such modifications. We gave it a rating of minimum. The failure consequence, it's a seal 2 one. We considered it as middle. High will be seal 3, seal 4. Innovation mode novelty, well, white. Nothing is innovative, it's just a fix of one line of code. Complexity, it's really easy, it's one line of code, and also we enforce within our process the use of the software metrics to define the complexity of a software. Monitoring, well, we have a bad one because it's really difficult to monitor the problem. We discovered the issue while the train was in operation, so we cannot change that. Reversibility is just a source code change, so it's really easy to change it back, so we gave it a 1 rating. And urgency, it's really urgent because we have some incidents in operation, so it's a really high urgency. The result of that will be low. For the other one, a bit similar. I would say the difference will be with the failure consequence, because even if the fix has to be made in the seal4 OS, we enforce in our process the use of segregation between the safety and the cybersecurity parts, so the failure consequence of the problem will be minimal. We get a rating of score, a score of 10, and the level of significance is still low.
So basically, when you look at these two examples, the result of the matrix gives us that low case, which means that for both systems, the software development process will be considered as minor modification, so we follow the section 9.2 of the standard. But we would like to adapt this a bit, but we call the application of the strict minimal effort, which is basically taking what is required by 50716, like software maintenance plan, software change record, software maintenance record, and software verification record, but also with additional elements which are required for basic integrity software. So this would be like a software maintenance, software requirement specification, interface specification, and so on, focusing, of course, on the elements which are modified, not on the complete software. So, and these elements will be performed according to the quality management process of the organization, and this is why we really need to have only capable and strong organization doing this, otherwise it will completely will not work. And next step is the assessment process. This will be minimal because we saw it's a low significance, so it means we will require for that a yearly letter of support. So what's the letter of support? It expresses the trust in the organization's ability to perform low significance evolution without a direct assessment by an assessor, which means that basically all the modifications are recorded inside a report, and once a year it's provided to the assessor, and he can recheck if you have forwarded, if all change requests are really not critical, and so on. And then based on that you get a letter saying that all these minor modifications you added, the patches, are covered by the new certificate.
So the version 2 of the process is finalized. It will be published by the end of the year. So the feedbacks are of course welcome because we are already working on the version 3 of the process. We are also welcoming experts to be part of the mirror group of the Primes team. If you want to participate, you are really welcome. Next year we'll make a new version which will concentrate on integration and testing activities. And we will also make the change request to the TSI CCS, the CSM risk assessment, and the EN 5716. It's our roadmap for next year.
Thanks for attention and happy to be here with you.
Thank you. Okay, so stay because we have some time for questions until lunch. So any questions from the audience?
The lunch is not ready.
The lunch is not ready, so we can be here until 1.
Half an hour. Sí.
Okay.
There is a
No questions?
in the chat. There's a comment. There's I think for you, there's a comment in the chat.
Okay, maybe you can.
Yeah, I mean, I just, so there's a question in the chat which you can see there. So they're planning to get the system rolled out. FRM, so as I said, FRM itself is highly secure, but as I said, the real challenges come when we add people and process. And I suppose, you know, I'm not an expert in railways. I have to be completely clear about that. But what I've identified is that is the problem, is how you do the interfacing to legacy systems. In particular, if you're trying to use if we look at the slides that I showed, the standard services within FRMCS are designed to operate within the context of that FRMCS system. As soon as you try and link it with other systems, so that's GSMR, or maybe it's an older technology or a bespoke technology for a particular situation, that's where the problem comes. So I suppose on one hand I'm trying to say, look, all is good, FRMCS is not going to be a problem. On the other hand, I'm saying how you deploy it will be the issue. That doesn't answer the question at all that the person is putting there. Thank you very much. But I suppose it's just pointing that that's a bit of work that really needs to be done. I'm interested in research in that area as well.
Thank you. I think we have a question there.
No, it's okay. Must be okay.
Hello? Okay. Within the system pillar working group, ISA and ASBO are already there, right? Or, I mean, have they accepted to follow this process or not? Or what is their feedback?
That's the good question, and I pushed since the beginning to say no one thought of inviting them in system pillar, and so they are not officially part. But in June, I was in Budapest because there was the ASBO Corporation Group meeting for all European ASBO, and I presented this topic plus another one for 1.5 hours, and they really asked me lots of questions, and they were really interested, and they said, so maybe it's too ambitious, maybe, and some said we need to go further. And also Roberto Sambrini, so from Alstom, who was really interested for the other part of the presentation for the generic safety case. And so they are really, now we are really in connection with them. And from this year, we wanted to have the complete, let's say, first steps completely set up to really ask ASBO to say, now we have, beside the testing part, everything, other parts are defined. So we have, as I said, I belong to ECOS, and we have sub-companies which are really focusing on ASBO and NOBO activities, and they will be called as a mirror group. But of course, the idea is to get their feedback internally and also from other ASBOs. And they are aware that the next set of the next publication will be done in October, and they will be asked to review. So it's scheduled from this year. That's a very good question.
Thank you.
Any other question from the audience? Yes, Paolo?
A little bit not technical question. Is there any estimation of how much is the impact of cybersecurity on the cost of a product due to the need to fulfill the additional requirements?
From our process or from cybersecurity, I would say no. The only thing we know is that if there is not this, say, clear separation of at the beginning, if it for existing project, it's always painful because if the system has not been designed with these segregation rules, it's a nightmare to implement. It's even impossible to implement it later. So it's really for new systems. So if you deploy it at the beginning, I would say not so much. You really have to look at the lifetime. You will take more time for let's say the first 10 phases of the V cycle, but the 11th month, which is the maintenance of the system for the 20 years, then if you get really everything separated with safe, non-safe, and so on, then you will really save a lot of money, especially in reassessment. So that's the idea. But for the initial cost, it's very hard to define because it depends also on the maturity of the organization. But maybe, yes, Marcus will have more, let's say, answer on this. He will have more experience.
Yeah, from a Siemens perspective, we have done a couple of projects for the initial cost. It's really minimal. It's under 1%, as we see. But the real cost comes in the lifetime of the system and the products. And I think both Julians have made a really good case of showing that the cost of updating the system, since security requires constant, regular patches, needs to be in place to not get this cost increased like crazy. When you think of a system for keeping a system 30 days secure, and how many security updates you would need. So we see from our products that use quite a lot of open source things, always every 1 or 2 years a big security issue that really, even if you protect it very well with the level of the system pillar, for example, from cybersecurity, you will have issues in TLS, you will have issues in other parts, and we saw this in the last 2 weeks, which really requires a security update. So we need a really good, proven method of assessing the impact and avoiding a recertification. And I think that the presentation we heard last time is a good direction into this. We also support this from UNISIC, so to separate safety and security. That's also a key part to keep the impact low. And another part that's really, really essential is stressed on the ERA conference. We need to reduce the varieties and the different national implementations. So we don't want to have national specific requirements that leads to a wide range of products that we need to support for the different countries. Because when I need in my product development to make a version for France, make a version for other parts, other countries, I need to maintain different version of my software, and this will increase if I need, let's say, 100,000 for updating the system. I need it to do for each version. I cannot share the cost. If I have a product that goes into all the different, it's a generic product, goes all the different things, I can divide it to 5 to 10 people. So the cost goes dramatically down. But if we insist, and that's what we are doing at the moment, that each project is an individual project with their own requirements, we end up not being able to share the cost. So it's both sides. We need the process that is slim and the separation of safety and security, and we need to go away from the national specificities.
We have a question in the chat, I think, for both. Julien?
So I will try to answer. First, to the last question, is EN 5716 already discussed with CSN area experts and agency? I don't think so on maintenance, because it's something the chapter really didn't change for many, many years. And I was this week in a meeting of the Senelec working group of EN 5716, and they are eager to get the results from our Europe's Rail working group to update that chapter. So we'll discuss with them a lot. For the second questions, I don't know honestly by heart the cybersecurity standards, but I know that they define some things between safety and cybersecurity, but I don't know the details. I know that within the EN 5716 they don't deal at all with cybersecurity. There are no requirements on that. It's just written somewhere in the beginning of the standard that balanced measures should be taken between cyber and safety, and that's it. So certainly the software standard has to be updated to handle cybersecurity evolutions. And for the first one, yes, The maintenance approach should be used for the cyber patch, but maybe not so much, because in our process we define also that if there is a clear segregation between cyber and safety, basically for cybersecurity evolutions we don't apply the software standard, we apply the cybersecurity standard. We have to apply the safety standard only when the segregation is not so clear and when I would say the cybersecurity impacts the safety-related software. I think we wrote it like that, basically.
Yeah. But it's true that basically what you say, the propagation of a cyber change inside software, it's easy to say you need to completely separate cybersecurity and safety, but then how to prove it, that will also be a big challenge, and it also depends how you build your architecture. Because I made a lot of C4 systems. When you have this on hardware level, it can be very easy if you have two boards. But if you get things on the same board, for instance, then you have to make much more analysis. So it really depends, I would say, how you create your architecture between the application, the hypervisors, and so on. But for sure, this is a main challenge. And if it's not properly thought at the beginning of the program, then it becomes a nightmare. And I think maybe even impossible. So there is no easy answer, but it's true that this question has to be thought at the very beginning of the new project, when assigning when defining the architecture, logical and physical architecture of a system. So I hope it helped a bit to answer, but yeah, it's not easy to answer without taking exact, let's say, concrete cases and so on this. Where is Serge? This was for you.
Yeah. What is Sergey?
Yeah.
Yeah. Okay.
Yeah. About the last questions, we are also, of course, discussing with the cybersecurity experts. So from the one from System Pillar, we have I would say a single point of contact within the groups with who we discuss often, and also with also some guys who are in the cybersecurity standardization groups, like certainly within cybersecurity, Quentin Rivet from SNCF is part of the group, so we discuss a lot.
Thank you. Any other questions in the audience? If not, I have a question for Gabriela and David. Oh, one more? Quentin. Okay. So you know that CISA recently published an advisory regarding this protocol, end of train, head of train remote linking protocol, which is not exactly the same as the case you described, but it has some similarities because it's also radio based. So in your view, does this public disclosure bring any benefit, or do you think it is beneficial for these investigations?
I'm really glad you asked that, because we have been through a lot these 2 years, and some people have accused us to create a pulling effect by disclosing our information. As important as the public disclosure or responsible disclosure is the responsible receivement of the information. If you are not available to us, to scientifics or to researchers, to receive this information and work in the process of fixing it, we have to make it public in any way, just to try and do that people, any kind of people, work and fix it. So yes, I'm completely in favor of the public disclosure, and if you want a more discreet disclosure, you have to be more responsible in the process of receiving the information. They were talking before about the cost of implementing cybersecurity measures. The real cost are the ones that of not implementing this kind of measure, because the real cost as are human lives. So which one is more important? Implementing this or not implementing them?
It's because cybersecurity is accumulative. So if you don't implement cybersecurity, you are taking risk over the time that they don't disappear. They are accumulative.
so they get worse. Yes?
Thank you. And since we have time, maybe a question to Omar. So, what is the feasibility of using AI to target rail systems, and which actors or group are most likely to use such technology today?
I think the likelihood is difficult to assess, but probably it's high because, as we saw, there is already malware, craft malware that is not targeting rail specifically, but that it's relying on artificial intelligence to create on the fly the scripts. And if we think how important is rail from geopolitical perspective, that has been always, not talking about cyber, but traditionally has been one of the main targets when there is a war to be looked at. And now with the digitalization and interconnectivity, it's much easier for threat actors to try to rely on digital cyber attacks to create either a disturbance on the service or going to safety impacts, as Gabriel and David mentioned. I'm sure even if nothing happened until now, nothing very serious. We saw, I think it was last week or 2 weeks ago, that in Ukraine the trains were stopped, probably because Russian attacks on them through cyber. But I'm sure this is going to just be a growing trend, and we will be seeing more and more cases. And artificial intelligence will be part of it, because now we are using for writing mails. So for sure it will be used also on the cyberspace.
Thank you. And maybe one question for Martin.
Oh, okay.
Okay. So how do you see the relationship between academia and railway organizations developing?
Okay, yeah. So I'm an academic, and if I look at, the 150 papers or so that I've published, probably only a very small handful have actually made it into something useful for industry. Sometimes that takes 10 or 15 years, but occasionally we've had something that's gone through more quickly. And I think the ones that had impact and worked quickly, where we've worked very closely with industry. At our university, one of the things we do is a very small scale projects, which are so €250,000 sort of euro, quite small projects relatively speaking, which would work very closely with industry, bringing the industry and academia together. And I think that's a very good model, and it would be good to see more of that happening Europe-wide. I think I've talked to colleagues in Europe that say there's less of those mechanisms in some parts of Europe. Some places there are. I think one of the things that we struggle with is getting data. So AI has been mentioned, Omar. I'm sure somehow you get access to the data, maybe through NDAs with organisations. It's much harder for academia to do that, which is why sometimes we come up with something that looks completely, to industry like it's crazy, because we don't get that information. So I think getting a better dialogue between industry and academia would really help us deliver something more quickly. Yes, we still want to do that speculative research, which might not end up going anywhere, because only a small portion of it really ends up being, deployed. But I think getting that dialogue better, working out ways that we could share data so that we can help each other would be something that I'd be very, very keen to see work with. Unfortunately, that probably doesn't mean using things like the EU data spaces, which require all data to be open. I think many organisations can't do that, but ways in which we could have one-to-one relationships, get access to data, so that we can start delivering innovation from research view would be a really good way to start. Thank you.
Thank you. And the two questions I had for Julian and Julian have already been made. So if you don't have any other questions, I think we can...
I have a question.
Okay, thank you.
I have a question for you. In fact, when do you think the process will start to be used in a country for real, and what needs to happen for this to happen?
We need to update the regulations, the standard also, the CSM. So I'd say several years. I think so.
Yeah, and this is why we entered in connection with the Hasbro Corporation Group, because basically they will have the mandate for the new CSMRA that should be published later, and they wanted also to be involved in this, to bring stones to modify this. But mainly it's the SMRA that should be impacted by this, and then small changes were identified in TSI CCS, for instance, and 5716. So small changes, but the big one is in the CSM standard, yes. And for the deadline, it depends how the CSM is under consultation to be updated, so it's a good time. And I heard also that there will be, they are also open in the Senate committee for some changes when I discussed it with Roberto in Budapest. So then it depends how motivated are the people there, or how useful they think what we propose is, and can be, I hope within 2 years we can see that, understand, maybe as an informative first, something like this.
I think it will be very useful considering the CRA that it's coming, because we can end in the situation that we have a regulation, European regulation obliging the manufacturers to provide vulnerability management, and then nobody using it because it's too costly, too complex to apply. So from time perspective, it will be very good to have those working as close as possible.
Yeah, that's a good point. I forgot to say something, is that basically as we are working in the umbrella of System Pillar, we are publishing also through System Pillar. So when the people or the suppliers will use the call for tenders, or the requirement from System Pillar and call for tenders, they can also ask for this. So they don't have to wait that it becomes officially standard. If they say they want to be fully compliant to System Pillar, inside they have let's say, the set of RAMS requirements, really defined as requirement, and then also the process itself. So it's the package with the System Pillar requirement, so it will be used at the same time.
José Antonio.
The lunch is ready, because I received a photo with the lunch. Today is a Spanish cocktail. Yesterday was an international cocktail, but today is more or less from typical Spanish dish. It's in the other building, that's yesterday, Alberto Lera 23, and the room is going to be locked after the seat. Thank you very much.